Good afternoon and welcome to the Angry Astronaut. Sometime in the early 2030s, a probe coming back from Mars may crash somewhere in the Utah desert, off course and off target from where it was intended to land. The probe then may be discovered by a small town in the region, which, like many small Utah towns, are not very well connected to the outside world, especially when we're talking about internet, television, that sort of things. And then, in a moment of supreme ignorance, the people who retrieve the probe open it, and within minutes the entire town is struck down by a disease which we have no immunity to. Am I talking about the plot to the Andromeda strain? Well, the Andromeda strain took place in New Mexico. The probe in question was called Scoop and was simply designed to accumulate meteoroids, that sort of thing, in low Earth orbit rather than coming back from Mars. But other than that, it's essentially the same. But this is almost precisely the scenario that we are going to be facing in the early 2030s when the Mars sample return mission comes back. It is scheduled to touch down somewhere in the deserts of Utah. It's not going to be using any parachute system. We can't be certain, as is the case with any atmospheric re-entry, that it is going to touch down on target. And if some unwitting passersby were to discover it and open up its contents before we could retrieve them, the disaster could be utterly cataclysmic. You may wonder, why are we allowing such a potentially dangerous cargo to return from Mars? Is there any real danger here? Is there any sort of possibility that if a foreign pathogen from Mars were introduced to our environment, to our species, that it could represent any sort of threat? Well, many exobiologists say no, that any pathogen that evolved on a different planet would have no ability to hitch a ride on any life form on our planet, or even if it did, it might be able to hitch a ride on a plant or something else relatively primitive, nothing as advanced as a mammalian species like ourselves. That the threat represented by any life coming from Mars, assuming that there's life there at all, is so negligible that we don't even need to be worried about it. But at the same time, there is a very sizable minority in the scientific community that is expressing extreme concern over this mission. The mission to finally retrieve samples from the surface of Mars and bring them back to Earth to prove definitively whether or not life existed on Mars in the past and whether it thrives currently. Are there alternatives? Are we saying that we shouldn't return these samples to our planet at all? Or is there another way to do it? And also, need we be concerned? How likely is it that life is going to be hitching a ride back on this probe? And even if it is, how likely is it that it could possibly be threatening to the human species? Well, the answers are a little surprising, and I have to admit, extremely disturbing. But probably the most compelling reason that we should not be bringing samples back from Mars and landing them on our own planet is because life almost certainly exists on the red planet, especially considering discoveries that have been made in the past and in recent years. So when the Perseverance mission was first announced, one of the things that absolutely frustrated me about it was the fact that it was not designed to actually detect life. That even though its mission was to find evidence of at least past life on the red planet, it had no instruments to definitively discover such life. Instead, an as yet undesigned Mars sample return mission would be necessary in order to deliver these samples back to Earth for analysis. Now, what you're watching right now is not the procedure that the Mars sample return is actually going to be undergoing. Instead, what's going to happen is the Mars sample return lander will retrieve samples that have already been deposited by the Perseverance rover across the landscape near or in the Jezero crater, and once these samples are returned, it will send them back to Earth on a small rocket, which, thanks to Mars' very low 1/3 gravity pull, is capable of escaping Mars gravity and making its way back to Earth fairly easily. And on board, it's going to be carrying what is both the most precious and the most lethal cargo in history: samples returned from the red planet that almost certainly are going to have at least evidence of past life and most probably living organisms on board. So why do I believe this? Oh, incidentally, by the way, these samples are going to be returned by two of the highly successful Ingenuity helicopters, or helicopters very similar to them. So why am I so concerned about this sample return, and why do so many scientists share my concern? Well, it's because with all of the evidence that we have accumulated since the first probes arrived on Mars in the 1970s, we now have overwhelming evidence that life thrives on the surface of Mars, and very well might thrive in a wide variety of different forms, at least if we're talking about microbial life. The Viking landers, as many of you know, at least if you've been following my channel, discovered very compelling evidence of life by means of something called the label release experiment. In this experiment, nutrients which probably existed on primordial Earth were introduced into samples of Martian regolith, and if that regolith then produced carbon dioxide as a byproduct, that would be a strong indicator that something was devouring these nutrients. And sure enough, the label release experiment produced positive results for both Viking 1 and 2. And by the way, this is the same experiment that's used on our planet to detect bacteria in drinking water. In other words, if it turns up positive, there is certainly bacteria in your drinking water and you should avoid it. This is something that, if it turned up a positive result on Earth, would definitely be proof of the existence of life, and is only held to a different level because the experiment was conducted on Mars. However, far more experiments were carried out by Viking to prove definitively that this positive result was actually showing us the existence of life rather than something else. For example, the Viking gathered up another sample, subjected the regolith to a substantial amount of heat, which should have been enough to kill any bacteria in the regolith, did the label release experiment again, and lo and behold, the experiment came up negative, as would be expected if the sample contained microbial life. But still, NASA was not satisfied. So after that, the Viking gathered up another sample of regolith and subjected it to a lesser amount of heat, an amount of heat that should have killed off a percentage of the bacteria, but not all of it. And lo and behold, when subjected to the label release experiment, the regolith produced a substantially reduced amount of CO2, just as was anticipated. And yet still, NASA was not satisfied. After that, the Viking flipped over a rock that would have protected the regolith underneath from cosmic rays that NASA determined might somehow be producing this result non-biologically. And once it flipped over this rock and gathered up another sample of regolith, subjected it to the same experiment, and lo and behold, it came up positive. So many different ways this experiment was carried out on the surface of Mars to determine absolutely, definitively that life existed. However, one experiment came up negative, and that was an experiment that was designed to detect organic carbon. Amazingly, that test came up negative, and as a result, NASA determined that Viking had not, at least not definitively, discovered life on the red planet. At least that there was some room for debate, and consequently, no announcement was made at all, and it took decades before Gilbert Levin and his colleague Patricia Strott announced that in their opinion they had discovered life on Mars in 1976. And sadly, both of those scientists who headed up this whole expedition back in the 70s have passed away and can no longer make their case. And in the meantime, exobiologists have become far more conservative than they were back then, which is unfortunate because it has also since been determined that Viking almost certainly did detect organic carbon back then, and if that had actually been announced, NASA would have acknowledged the presence of life back in 1976, and we would be having a very different argument today. So what were those discoveries? Well, first, let's have a look at how NASA intends to deliver this sample back to our planet. Amazingly enough, this sample is going to be delivered to the middle of the continental United States, but in an isolated region called the Utah Test and Training Range. As you can see, however, it's rather disturbingly close to the Great Salt Lake and to Salt Lake City in general. If it goes off course even a little bit, it might land in a populated area. In addition to that, as I mentioned before, the capsule will endure a fiery plunge to Earth without a parachute and land within a dry lake bed within this area. And in spite of impacting at roughly 150 kilometers per hour, the capsule will keep its samples intact and isolated. And once recovered, it will be placed in its own environmentally controlled protective container and then shipped off to an off-site sample receiving facility. Such a facility will resemble today's biolabs that study highly infectious pathogens, incorporating multi-layered decontamination measures, air filtration systems, negative pressure ventilation, and other safeguards. But again, here's the problem. What if the capsule goes off course? What if it gets damaged during re-entry? And what if somebody stumbles across it before NASA gets to it? Is there a real danger here? Well, let's go back to discoveries that were made by the Curiosity rover decades after Viking made its discoveries. Interestingly enough, Curiosity was not designed to detect life, but rather to detect evidence of both past and current water on Mars, and it made discoveries almost immediately after arrival. First of all, it discovered smooth, rounded pebbles that likely rolled downstream for at least a few miles in a river that was ankle to hip deep millions of years ago. And as Curiosity kept exploring, it became increasingly clear that Mars, at least in the past, was perfectly well suited to the existence of life, at least microbial life. For example, a sample rock that was gathered by the Curiosity, a piece of fine-grained mudstone containing clay minerals, sulfate minerals, and other chemicals, was determined to contain sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon, some of the key chemical ingredients for life. In addition to that, the ancient wet environment on Mars, unlike some other regions, was not harshly oxidizing, acidic, or extremely salty, perfectly suitable to the development of at least microbial life and perhaps certain types of multicellular life. And the discoveries just kept coming. Paul Mahaffey, a principal investigator at NASA's Goddard Space Flight Center, had the following to say, quote, "The range of chemical ingredients we have identified in the sample is impressive, and it suggests pairings such as sulfates and sulfides that indicate a possible chemical energy source for microorganisms," unquote. And during its mission, Curiosity examined what turned out to be a habitable environment characterized by a neutral pH chemical gradient that would have created elevated energy for microbes and a distinctly low salinity, which would have helped metabolism if microorganisms had ever been present. In other words, ancient Mars was perfectly suited for life to evolve and thrive. But why would it not have disappeared later on? Well, here's the thing. Once life actually gets started, as we have seen here on Earth, it has a tendency to be able to survive even the most horrific of environments, even in environments that contain no liquid water at all. Keep in mind that as near as we can tell, Mars did not experience a sudden cataclysmic event that made it uninhabitable. The entire process took many millions of years. And during that time, there's no reason why evolution shouldn't have provided at least some microorganisms with an avenue towards survival. As long as water exists in some form on the surface of Mars, or even beneath its surface, which it definitely does, the potential for life to thrive on Mars is still definitely there. And there's every reason to believe that Viking 1 and 2 should have detected life even in the relatively inhospitable environments where it set down. That being the case, though, this is not the only evidence that Curiosity was able to discover. There was also evidence of active organic chemistry taking place in the Martian atmosphere right now. Plus, organic carbon was detected by the Curiosity rover from a variety of samples taken in the region. That same organic carbon that was not found by Viking was determined to be difficult to find because of the presence of perchlorates in the Martian regolith, something that the Viking researchers didn't know existed. Had Viking possessed the same instruments that Curiosity has while looking for organic carbon, and almost certainly would have found it, and the existence of life would have been confirmed back in 1976 when the standards weren't quite so high as they are today. Now, of course, it might have been debated since then, but it still would have created a very, very different environment for sample return missions today. And that's not the only evidence, obviously. On top of that, as some of you have probably heard, Curiosity detected strange seasonal spikes of both methane and oxygen in the Martian atmosphere. The methane was particularly noticeable. We're talking 10 times the average level of methane in the Martian atmosphere that were detected in 4 different measurements between late 2013 and early 2014 during the Martian summer. And by the way, the spikes in oxygen in the Martian atmosphere also took place during the Martian summer. This sudden dramatic shift in atmospheric composition is very, very difficult to explain inorganically. Perhaps a sudden flare-up of volcanism, but why would that take place seasonally during the Martian summer? It would be a massive coincidence if something like that were to happen. Moreover, the sudden spike in oxygen would not be explained by a sudden increase in volcanism in the region. Only organic activity seems to be a perfect fit for this particular chemical shift. That being the case, though, it's not absolute proof. Nevertheless, if you combine this proof with the organic chemicals discovered in the regolith and with the extremely habitable nature of ancient Mars, especially given all of the water that is still present there, yes, granted, in frozen form these days, but given the liquid water that flowed on Mars' surface in the past and the extremely habitable environment that it once created, there is every reason to believe that at least some form of microbial life still thrives on the surface of Mars, especially if you combine all of this evidence with the results of the label release experiment back in 1976. That being the case, then, there's every reason to believe that the samples that are going to be brought back in the early 2030s may not only contain evidence for life, but that these samples may actually be brimming over with life. life that in theory could be very dangerous to our civilization. And for this reason, a group of concerned scientists formed the International Committee Against Mars Sample Return, and their mission is very straightforward, in my opinion, very, very logical. Quote, "In the light of the loss due to human error of many of the spacecraft sent to Mars over the course of the space age, the International Committee Against Mars Sample Return urges the scientific and environmental communities to consider avoiding the return of Martian samples directly to Earth, as problems with electronic circuitry malfunctions are common, as well as accidental impacts. The study of Martian soil and rocks for signs of life can be accomplished with in situ life detection instruments on Mars, something NASA has not done since the twin Viking mission in 1976. The question must be asked, do the benefits of studying Martian samples in laboratories on Earth outweigh the risk of contaminating our world? We have only one Earth." Two of the NASA Viking biologist team astrobiologists, Gilbert Levin and Patricia Ann Strott, have published numerous papers stating they believe that their biology instrument, called the Labeled Release Experiment Instrument, discovered living microorganisms in the Martian soil. The organization goes on to quote Carl Sagan from his book Cosmic Connection: An Extraterrestrial Perspective. Quote, "Precisely because Mars is an environment of great biological interest, it is possible that on Mars there are pathogens, organisms which, if transported to the terrestrial environment, might do enormous biological damage. A Martian plague, the twist in the plot of H.G. Wells' War of the Worlds, but in reverse. This is an extremely grave point. On the one hand, we can argue that Martian organisms cannot cause any serious problems to terrestrial organisms because there has been no biological contact for 4.5 billion years between Martian and terrestrial organisms. On the other hand, we can argue equally well that terrestrial organisms have evolved no defenses against potential Martian pathogens precisely because there has been no such contact for 4.5 billion years. The chance of such an infection may be very small, but the hazards, if it occurs, are certainly very high." And here's the most important question. Does NASA, does the United States have the right to take a risk like this on behalf of the entire planet? This would seem to be a bit arrogant, a bit presumptuous, and the only reason, in my opinion, that there hasn't been worldwide outrage over this situation is because the vast majority of people have no idea that this is about to happen. Only NASA and ESA are actively involved, and that represents a very small percentage of the general populations of all of the member nations that are participating in this mission. Is this a fair thing for us to be doing, especially when a much better alternative exists? The Lunar Gateway, one of its primary missions, was to act as a staging area, a quarantine zone for any potentially hostile organisms being brought from other planets. Why not have the Mars Sample Return mission dock with the Lunar Gateway first and have the scientists on board extensively test the samples before risking their return to Earth? It would be no more difficult technologically or logistically, assuming that the space station exists around the moon in the early 1930s, which it's supposed to do anyway, and at the same time, it would also make it unnecessary for the sample return mission to experience a fiery return through Earth's atmosphere. No dangerous re-entry, no 150 kilometer per hour impact. The samples would almost certainly survive intact if they were to dock with this space station. And once again, this is one of the most important missions that the Lunar Gateway has anyway. Why is NASA refusing to use it? Regrettably, the time for public commentary on this mission is past. The only way to get NASA to change the mission parameters is to do so through international negotiation. And perhaps we should start considering approaching our respective governments and and asking them to take action, because regardless of how small the risk may be, there's no sense taking a risk with the health of the entire planet when a better alternative exists. And we are playing with fire if we assume that the discovery that Gilbert Levin and Patricia Strott made back in 1976 is something to be casually ignored or discarded, that the life that they found almost a half a century ago presents no threat to us when we know absolutely nothing about it. Smash that like, hit that subscribe, please hit those notification bells, and also please check the description for various ways to support this content, and as always, stay angry about space.